We are now streaming live. It is the top of the hour, and the president of the San Francisco Amateur Astronomers is not able to join us this evening and asked that I deliver her remarks. So I got three things to say, and I neglected to read these up front. So let's see. If anyone is interested in possibly joining the speaker committee, have them email president@sfaa-astronomy.org. So that's the first note. The second note, the next members only star party on TAM is Saturday, July 30th. And finally, the third note for me to read, remind members that attend the star party that they have to check in with the lead at the latest half an hour before sunset. Once they have checked in with the lead, they can go watch the sunset until it's time for the huddle, but without the check-in, they're not guaranteed space at the star party, as the lead does not know who is in the parking lot, who's there for the star party versus general public without that check-in. So those are the three remarks I was asked to read, and I apologize, I had a busy day, so I did not read them in advance. Thanks everyone for coming. Again, my name's Jay and I'm running tech. I'm going to turn it over to Linda.
Greetings, everyone. I'm reminding everybody that we meet on the third Wednesdays of each month. And yes, I am retiring at the end of the year. I will have had 18 years and 209 speakers over that period of time. And I loved every minute, absolutely loved every minute of it. We're having a very, very interesting talk next month called The World's Largest International Dark Sky Preserve. On April the 7th, I read on physics.org about this world's largest international dark sky reserve with 15,000 square miles located in southern Texas and northern Mexico. I contacted the International Dark Sky Association in Tucson, asking if someone could speak to SFAA on their participation in this historic project. SFAA has a link to the article that was published in April, which includes a map of the whole area that is the Dark Sky Preserve on the website homepage below lectures description under Club Resources. And SFAA is also a member of the International Dark Sky Association. The lecture will be on August the 17th, and we will hear from Stephen Hummel of the University of Texas, Austin, and he's with the McDonald Observatory, which is one of the largest telescopes in the world. Also speaking will be Amber Harrison with the International Dark Sky Association. There have been very few talks on the IDA in the Bay Area over the years, but SFAA is reaching out to the Astronomical Association of Northern California to suggest that they join us also on Zoom and YouTube and Facebook on August the 17th. And it will also be recorded in our archive. So I'm hoping that you'll tell friends who are interested in this subject, and we'll have a lot of people coming to hear about this new and important location. Then on Wednesday, September 21st, Jessica Liu, Associate Professor of Astronomy at UC Berkeley, will be speaking on searching for black holes in the Milky Way. The population of black holes left over from dead stars in the Milky Way is almost entirely unexplored. As a result, many basic properties of black holes remain uncertain, including the total number of black holes in the Milky Way and their masses and so forth. Dr. Liu will describe how the known number of black holes will increase 100 times at least over the next decade. After she agreed to speak to us on June 10th, I looked at physics.org, which I recommend to everybody. There's so many subjects that you can research on physics.org. They published a paper titled, "Astronomers May Have Detected a Dark Free-Floating Black Hole in the Milky Way." The team was co-led by our speaker, Dr. Jessica Liu, and she's been looking for free-floating black holes since 2008. On June 10th, the same day that this paper was presented, the story was also on CBS Evening News, featuring Jessica Liu and the discovery of this free-floating black hole in the Milky Way. So please join us for that talk as well. Tonight, we're delighted to have Ken Lum join us again for part 2 about travels with the Antique Telescope Society. And Ken Lum is a retired ER doctor who became interested in astronomy and its history while in high school. He was inspired by the space race in the 1960s. Having built a telescope at the Adler Planetarium in Chicago, where he grew up, he also became interested in the history of the telescope. After dropping out of astronomy during college to pursue other studies, he became interested in, actually studies in medicine, he became interested in starting to work. He currently uses a unistellar EV scope, a Celestron C 925, an AP Traveler, and a Takahashi Sky 90 refractor for most of his observations. So he's one of us for sure. He joined the Antique Telescope Society in 1994, 2 years after its founding, when the society came west to tour the Lick Observatory, the old Chabot Observatory, and the Ricard Observatory at the University of Santa Clara. He's continued to attend many of the ATS tours and meetings over the years until they were temporarily halted because of the pandemic. We welcome Ken Lum's second talk about travels into astronomy history. Welcome, Ken Lum.
Okay, thank you very much. Very nice introduction. So I have to share screen, I guess.
Yes, the large green button at the bottom center.
Okay, let me select that, click on it, and everybody can see that?
I see your PowerPoint application.
Okay, let me, I need to get to, oh, there we go. Okay, let me get the.
Okay, now I see the slide with the castle.
Yeah, okay. So thanks everyone for coming back for a second time to see the second half of my tour through the history of the telescope as seen through the travels with the Antique Telescope Society. And we'll hear more about this big telescope a little later. Okay, so let me see, how do I, oh, okay. Okay, I just want to review some of the things that we covered last time, which is the invention of the refractor telescope was in 1608 by Hans Lippershey in the Netherlands. Then Isaac Newton invented the reflecting telescope in 1668. And then the Dolans developed the achromatic refractor in the early part of the 18th century. And then high precision mountings derived from metalwork techniques coming out of the Industrial Revolution became available for telescopes in the late 18th century, mostly under the work of Jesse Ramsden. And then the reflecting telescopes began to become very large light buckets, mostly under the efforts of William Herschel in England in the latter half of the 18th century. Okay, there we go. So these are just some examples of 17th century telescopes that we saw in Middelburg in the Netherlands in 2008. Let's see, here's Isaac Newton's second reflecting telescope that we still have now in the possession of the Royal Society in London. And here's a typical Dolan achromatic refractor that was used as a telescope, mostly probably for military use. And then Jesse Ramsden started building these very high precision mountings for small refracting telescopes, and they were small because it was the difficulty of making optical glass at that time. All right, so here's one of the light buckets that William Herschel developed the reflecting telescope into his 18-inch 20-foot long reflector, which was actually his favorite telescope. All right, so what happened in the 19th century was that the spectroscope was invented in 1814 by Joseph Fraunhofer, and then applications for it began to take hold in the 1860s. There were improvements in the making of optical glass, allowing bigger pieces of lens making glass that was uniform enough for making refractor telescopes. Then the technique of chemically applying reflective silver on glass mirrors was invented in the 1860s, And we'll talk about that in a little bit, and that greatly improved upon the dependency on specular metal mirrors to improve reflecting telescopes. Then very large mountings became available in the late 19th century so that they could handle big telescopes better and better. And then finally, most very importantly, astronomical photography was invented in the latter half of the 19th century. Okay, well, anyway, there was an interesting quotation from Auguste Comte, who was the father of sociology, interestingly enough. So you kind of wonder, how he got interested in making a comment on astronomy. But anyway, he said in 1835, on the subject of stars, all investigations which are not ultimately reducible to simple visual observations are necessarily denied to us. While we can conceive of the possibility of determining their shapes, their sizes, and their motions, we shall never be able by any means to study their chemical composition or their mineralogical structure. Our knowledge concerning these gaseous envelopes is necessarily limited to their existence, size, and refractive power. We shall not at all be able to determine their chemical composition or even their density. I regard any notion concerning the true mean temperature of the various stars as forever denied to us. Well, that's kind of a gauntlet thrown out, to say the least. Let me see, how do I? Yeah, okay, so anyway, that situation started to change just a few years after he made around that same time, and it started with this gentleman, Joseph Fraunhofer, who was born. I can't see. I got to move some of this out of the way. Okay, he was born in 1787 in Germany, and at the age of 11, he was orphaned, and both of his parents died, and he was then connected up with a fellow by the name of Weisselberger, who was a glassmaker in Munich. Unfortunately, Weisselberger started used him kind of as a child slave to do work around his workshop. And one day when he was around age 14, he was working in the workshop when the roof of the workshop collapsed and fell down on him. Unfortunately, the collapse killed Weisselberger's wife, but a large beam fell across young Joseph and shielded him from all the debris that was coming down. He was subsequently rescued from this collapse, and the rescue was witnessed by two very important gentlemen. One was a lawyer in Munich by the name of Joseph Uschneider, and the other person was the local Habsburg prince, a fellow by the name of Maximilian IV Joseph. And after he was pulled out of the wreckage, Maximilian found out that he was not being allowed to go to school by Weisselberger. And so he was offered an opportunity to get an education. And to the delight of everybody, he turned out to be an excellent student. And he subsequently grew up and went to work in the new Munich Institute that Uschneider had set up to build optical instruments. And there he thrived and invented a number of very important inventions, which included the spectroscope, which came out of work that he was doing to try and determine the refractive index of different colors of light through different samples of glass. He also invented the diffraction grating, curiously enough. And then he went on, and as I will show you, to invent the German equatorial mount, which everybody here is familiar with regards to mounting telescopes. Let's see. Okay, well, here's an illustration of Fraunhofer demonstrating his then newly invented spectroscope here. And when he turned his spectroscope to the sun, he found these many absorption lines in its spectrum. Of course, being a tradesman and not a physicist, he didn't really understand what they were. And indeed, physicists also didn't know what they were either, but he cataloged them, and they have some 500 of them. They have become known as Fraunhofer lines. Okay, well, what to make of these lines ultimately fell to these two gentlemen, Gustav Kirchhoff and Robert Bunsen, who were both professors at the University of Heidelberg. And around 1860, they developed another spectroscope for themselves, but instead of looking at the stars, they used this to look at chemical substances which were burned in what is now known as a Bunsen burner, because Robert Bunsen had a hand in developing that, although it was actually a staff workman who worked for Bunsen, who actually invented the thing. But nonetheless, they were able to correspond many of the spectral lines to particular substances. And so they discovered that the chemical makeup of something could be determined by the spectral lines that that substance produced when it was burned in a Bunsen burner. The first person to apply that notion to astronomy was this Englishman by the name of William Huggins. He made a lot of money in business, and when he retired from that, he decided to buy a telescope and see what he could do with it. So he purchased an 8-inch Clark refractor from Alvin Clark in the U.S. Around 1860, and built this telescope in his backyard. And he wasn't while he used the thing to do a little stargazing, he kind of wondered if there was anything serious that he could do with it. And so he read of Kirchhoff and Bunsen's work on spectroscopy, and he decided to turn this telescope to do spectroscopy of the stars. And so he started to discover the substances that made up stars that August Comte thought would never be able to do. And in this work, he was assisted by his wife, Lady Margaret Huggins, with whom she authored many of the papers and atlases of stellar spectra that they had put together. And she continued doing that publishing work after Huggins's death later on. Here's a drawing of the astrophysical laboratory, the first astrophysical laboratory ever that Huggins was using. You can see that there are instrumentation around the floor which are used to produce calibration spectra for use in comparing with the spectra that was obtained from stars here. The fate of the 8-inch lens belonging to that telescope, it has an interesting story behind it for those of you who are interested in the collection of artifacts. In 1868, the telescope was dismantled, but the lens was sold off to a whole series of owners for about a century. And then it ultimately ended up in the hands of the Cincinnati Astronomical Society in Ohio, if you can possibly imagine that. What really happened was that the Cincinnati Society had this 8-inch Clark refractor that you see here. And in 1981, the original lens to that, which was made in 1880, was stolen. And so they purchased the Huggins lens as a replacement, and that's how it ended up on this telescope. But later on in 1999, the thief evidently was looking to offer it to a university, either for sale or, from what I read, maybe as an effort to try and get a job at that university. So word got out to a couple of the members of the Antique Telescope Society, and they got a hold of the FBI, who then descended on this gentleman's residence and evidently made him an offer he couldn't refuse. so anyway, both the 1880 lens and the 1860 lens are now Huggins lens are now in the possession of the Cincinnati Astronomical Society. And if you want to see it, you can actually go to Ohio and take a look at the first component of the first telescope that was used for astronomical spectroscopy. Now, one of the important things that the Huggins did with the spectroscopy was to find a way to distinguish between faint fuzzies that were made of stars versus faint fuzzies that were made of gas. The faint fuzzies that were made of stars, like star clusters, galaxies, and so forth, produced absorption lines in their spectra, whereas gaseous nebulae produced emission lines. And so that distinction, like for example, in the case of planetary nebula and emission nebulae. And so that was a method that he developed to distinguish between faint fuzzies that were gaseous versus faint fuzzies that were made of stars. Okay. Anyway, as far as glass making is concerned, improvements in glass making started off in the early 19th century and late 18th century under the work of this Swiss glassmaker by the name of Pierre-Louis Guignon. I think you had a talk about him quite a few years ago, maybe about a decade ago, by Shiloh Unruh, who worked for Lick Observatory. And Unruh actually toured his house in Switzerland and in the south of France and he was able to dig up old samples of glass that Guignon had made when he was experimenting with glass. But anyway, he developed better methods of stirring molten glass that allowed him to make bigger discs of optical glass, all the way up to 12 inches actually. And this was a big improvement over the small samples of optical glass that were available to telescope makers at the time. Now, his work got the attention of Josef Utzschneider, who was running the Munich Institute where Fraunhofer worked, and both of them joined the Munich Institute in 1806. Unfortunately, while both of them were steeped in the chemistry of glass, neither of them seemed to be particularly steeped in the chemistry of each other. So Guignon began to complain that the young Fraunhofer was treating him like a smart aleck, and so it got to be so bad that Utzschneider had to intervene, and it was agreed that Guignon would leave the Munich Institute and go into retirement. There was a non-compete clause. There was a non-compete contract that Utzschneider offered to Guignon that if he stopped experimenting with glass, he would get a lifetime stipend to live out the rest of his life. Well, Guignon unfortunately couldn't keep his hands off glass, and he continued to experiment with glass. And Utzschneider found out about this and rescinded the offer of the stipend. But nonetheless, Guignon didn't worry about that because he was actually quite successful at developing new techniques for making larger optical glass discs. And his techniques were bought out by by an employee by the name of Georges Bouton, who took these techniques to England and joined a company called the Chance Brothers. And the Chance Brothers became, in England, the primary source of optical glass there. Guignon's son, Henri Guignon, moved to Paris and took the same techniques and joined a company that ultimately became the Paramantois company that became the primary source of optical glass in France. Unfortunately, Fraunhofer died at a young age of 39 in 1826 for unknown reasons, so he sort of drops out of the scene. But not before he built some very significant telescopes, which included this great refractor of 1824, which was used at the Dorpat Observatory in Estonia by Wilhelm Struve to do double star work, and was also used to establish a parallax for the star Vega. Let me just take a look here. And It also was used to measure take the first measures of the diameters of the Galilean moons. And as you can see, we still have that telescope with us. It's a museum piece on display at the Dorpat Observatory in Estonia. So if you go to Estonia for any reason, there's an opportunity to actually see the telescope. The mounting of the telescope that you see here is the world's first German equatorial mount. And it was Fraunhofer's invention, and I think the telescope has a diameter of 9.5 inches, and so we still have this telescope is still evidently in good condition. All right, let's see. Now, subsequently, in 1835, Fraunhofer built a nearly identical telescope, also about 9.6 inches, and this telescope was installed at the Berlin Observatory, where in 1846, Johann Galle, at the urging of Urbain Le Verrier in France, he was urged to look for the predicted position of a trans-Uranian planet that Le Verrier had predicted to exist mathematically. Similarly, John Couch Adams had done the same kind of thing in England, and it made independently made a mathematical prediction of the existence of a trans-Uranian planet. And on the very first night of looking for the planet, with the assistance of Louis de Rest, Galle actually found the planet Neptune, the planet Neptune, and made this great discovery. So John Couch Adams, Urbain Le Verrier in France, in Paris, and Johann Galle in Berlin share equal credit for having discovered the planet Neptune. And this telescope is still with us. It's in the possession of the Deutsches Museum in Munich, and you can go there to see it if you go visit that museum. It's a fantastic museum on scientific instruments and industrial and the Industrial Revolution as it was expressed in Germany. So this is just great to have this. Okay, well, glass making in Germany took a somewhat different route. It was started as a result of the establishment of the Carl Zeiss Optics company, which was actually mostly interested in making and selling and maintaining microscopes. So Carl Zeiss founded his company in 1847 in Jena, Germany, and he went on to hire this gentleman, Ernst Abbe, who was a physicist, and he went on to put optical design on a mathematical basis. And so he basically developed the practice of ray tracing for the design of optical instruments. And then on the glass making end, Otto Schott came in, was taken on by the Zeiss company to establish methods for making good optical glass. Now the Schott company is still there. By the way, here are some telescopes that the Zeiss company has made over the years. This is a 12-inch Zeiss refractor that's actually located down in Los Angeles at the Griffith Observatory. It was installed there in 1935, just before the onset of the Second World War. Is still operational, and it is the primary public telescope down in LA. What's interesting, let me go back actually. What's interesting also about this telescope is this unique type of equatorial mount, which has a declination axis going through here. I don't know if you can see that. And then there are two counterbalanced arms that stretch out from the sides that counterbalance the optical tube. And a similar kind of setup is this 1 meter reflector, Cancigarian reflector that was installed at the Hamburg Observatory with a similar kind of mounting. And that telescope is still operational. Fortunately, the Hamburg Observatory did not get bombed in the Second World War. It's in a suburb of Hamburg called Bergedorf. And while Hamburg was firebombed and thoroughly destroyed, Bergedorf escaped any damage. Okay, well, Zeiss also made the optics for this interesting observatory, which we visited in Potsdam in 2012. It's called the Einstein Solar Tower, and it was installed there in 1924, at which time Einstein was quite famous for having come up with the theories of relativity. And so Einstein actually visited this observatory, and when the architect asked him what he thought of the building, he said that the building looked organic, which whatever he meant by that. And in the next view, you can sort of see what happens to the members of the Antique Telescope Society when they come in contact with these observatories, because they also become a little bit organic as well. All right, so anyway, Schott set up a glassworks in Jena, and it's still there. There's even a museum to the making of glass, which you can visit if you go to Jena. Jena is in East Germany, actually, and so before German reunification, you couldn't actually go there, but you can go there now. And this is the interior of the museum. And there's also a separate museum to instruments made by the Zeiss company, mostly consisting of microscopes, but also lots of telescopes as well. And here's some examples of some of the old telescopes in the Zeiss Optical Museum. Okay, well, reflectors had hit a zenith with the Herschels around the 1790s when he built his 48-inch 40-foot telescope, but things kind of sat there for a while. And then this gentleman came along in Ireland, William Parsons, the third Earl of Ross. And he got interested in astronomy and wanted to build the world's biggest telescope. And we visited what was the world's biggest telescope in the 1840s in 2002, and we were given a tour by this gentleman who is William Brendan Parsons, and he is the great great grandson of the third Earl, and actually is a resident at Burr Castle at that place. Behind us is a building that contains an astronomical museum with many artifacts from the Ross estate that is related to their astronomical activities back in the 19th century. The telescope was in a state of disrepair. It was used from the mid 1840s until the 1870s or 80s, and it was basically a wooden tube in the form of a Newtonian telescope that was like a transit instrument. It had to be hauled up on a chain through a pulley, and then pulled up to point up at the sky. The observing platform is up here, is a wooden framework here, and surprisingly enough, they let us climb around all over the telescope when we were there, and you can see what that looks like. And this was a drawing of the telescope in its heyday, and this is what the tube assembly looks like today. It was restored in the 1990s. Let me see, by this gentleman on the left, Michael Tuberty. He's a retired engineer. The gentleman on the right is Kevin Johnson, who is a curator of antique scientific instruments at the Science Museum in London. Let me go back, and here's the universal joint that is located at the base of the tube assembly that allows the telescope to be raised, and then it can also be moved somewhat to a limited extent from side to side to allow some tracking of the object that the observer is looking at. Okay, here's the rather rickety looking a pulley system that was used to pull up the tube assembly. And then here's the winch. The gentleman that's standing next to the winch is Rolf Villach. He's a historian of the origins of the telescope in the Netherlands, and who was coming with us on the tour. And you can see what it's like to be hanging up there on the observing platform. It's quite a bit of a drop down there, and so because this is definitely not a safe way to observe, the telescope, although it's been restored, is not normally used for the general public to look through. Although during the restoration back in the 1990s, the original mirror was replaced by a lightweight aluminum mirror, metal mirror, which is good enough to allow you to look through the eyepiece while the tube is lying down up at a bit of the sky to see stars. But and actually the star images don't look all that bad, but it's not a safe telescope to use. Okay, you can see what the drop looks like. That's Ken Lum and Peter Abrahams from the Society dangling from the end of the observing platform. Okay, there's yours truly. In the background is the residence of the Lords of Ross, where the family has lived for many generations since the 17th century. Actually, there was once upon a time the castle was laid siege to, and scattered around the grounds are some old cannon left over from that time, during which time the Parsons family is in the 17th century were actually chased out of the castle and had to go into exile in England for a while before coming back and chasing the attackers out of the castle and reclaiming their land. Okay, many of you may remember this gentleman, Carter Roberts, who used to be active in the East Bay Astronomical Society, and here he's posing with the entrance to one of the workshops on the estate, and this is what that entrance to the workshop looked like in its heyday, with one of the 72-inch mirrors that were used for this big telescope. One of the original mirrors is still around, and this is it. It's on display at the Science Museum in London. So if you go there and look at their astronomical exhibits, you can take a look at one of the original mirrors belonging to this telescope. Now this telescope was before the advent of astronomical photography, and these are simply some of the pencil drawings that a couple of the pencil drawings that Lord Ross did of M51, one back in 1845 and another one in 1850. To the left is a drawing of M51 by William Herschel, or Sir John Herschel, I'm not sure which of the Herschels, using probably the 18-inch 20-foot telescope that they had made in England. And then on the far right is a CCD image, a modern CCD image for comparison. So you get a chance to see what people were able to see of spiral nebulae back in the days of pencil and paper rather than photography. This is what M33 looked like to Lord Ross, and you can see how that corresponds to a modern photograph. And this is the Crab Nebula, also drawn by Lord Ross back in the 1840s and 50s. Okay, well, anyway, that was the state of reflecting telescopes in the 1840s. And you can see it was a big, cumbersome affair that required a large staff of people to manipulate the telescope and was very cumbersome to use. This gentleman, an Irish telescope maker by the name of Sir Thomas Grubb, came along in the mid-19th century and attempted to improve on specular metal mirror reflecting telescopes. And one of his bigger telescopes was a telescope called the Great Melbourne Reflector, which is a 48-inch telescope that was installed, was the first big telescope installed down in Australia. And the observing program that they had for this telescope was to look for faint fuzzies, just like Herschel and Messier and Parsons did before them. And but they were going to do it for the southern hemisphere. And so this telescope was set up there, but it proved to be a very unstable and unwieldy telescope, and the specular metal mirror was difficult to keep polished up and properly figured. The problem with specular metal mirrors is that they eventually tarnish, and in order to polish the thing back to a reflective coating, to a reflective surface, you end up destroying the figure. And so not only do you have to repolish the mirror periodically, but you also afterwards have to refigure the figure of the refigure the surface of the mirror so that it actually works. And that proved to be too difficult to do down in Australia. They didn't have all the skills necessary to do that work. And so this telescope sort of failed. And actually, as a result of the failure of this telescope, many astronomers lost confidence in reflecting telescopes, and so for the second half of the 19th century, astronomers primarily emphasized the use of refracting telescopes because they were a sure, more tried and true technology that they could reliably use. The mounting of this telescope was subsequently recycled as a mounting for this 50-inch telescope that was located at the Mount Stromlo Observatory in Australia. But unfortunately, in 2003, a wildfire burned down the observatory and destroyed the telescope. However, the mounting, which dates from the 1869 construction, has been retrieved and is being restored and remated with its original tube assembly. And the volunteers who are doing that work are hoping to resurrect the Great Melbourne Reflector as a public telescope at some time. I do not know what the progress is, but the last I saw was that the pieces were all assembled, but whether it's useful or not is not. I'm not sure. Anyway, it's a hard luck telescope, and so everybody had to wait for some improvements on reflecting telescopes. That came in the person of this chemist in Germany by the name of Justus von Liebig, and in the 1860s, he improved upon a chemical method for depositing reflective silver on glass. And then this French physicist by the name of Jean Foucault, whom everybody knows from the Foucault pendulum, applied it to the first astronomical reflector to incorporate a silver on glass reflective surface. And that was this 13-inch telescope, which he built in 1864, I believe. And we still have it. I understand this this telescope is on display at the Marseille Observatory in southern France. So if you're ever in the city of Marseille, you might want to, I have not actually gone there myself, you might want to check out the observatory and take a look at the first silver on glass reflecting telescope in the world. Foucault also went on to invent the Foucault knife edge test for testing the figure of parabolic mirrors, and most of you know about that. Okay, well, anyway, back in Germany, after Fraunhofer's death, two gentlemen, Georg Merz, who was a telescope maker, and Josef Mahler, whom I couldn't find much information on. I kept getting Gustav Mahler, who was a musician and composer, but I couldn't find much on Josef Mahler. But Merz and Mahler took over from Fraunhofer to build telescopes at the Munich Institute. And in France, the principal telescope maker was a fellow by the name of Paul Gautier. I couldn't find much information about him either, at least not on the internet. But he was responsible for making the lenses of photographic telescopes that were involved in the first effort to do a photographic atlas of the sky in the latter part of the 19th century, called the Carte du Ciel. So anyway, but refractors became the primary instrument of astronomers in the latter part of the 19th century. And the first serious American telescope maker to come on the scene was this fellow, Henry Fitz. And he set up a workshop in the 1830s and 40s in New York City. And there he made numerous kinds of smaller refracting telescopes, some of which have come down to us. Last time I showed you a picture of one that was retrieved from a dumpster, actually, and restored. And then, of course, the most preeminent telescope makers in America were the Clarks, father and the sons, Alvin G. Clark and George Graham Clark on the right. And they established a telescope making concern in what was known then as Cambridgeport, Massachusetts, which is in Cambridge, Massachusetts, not surprisingly. And they went on to build some of the biggest telescopes, refracting telescopes ever made. And we'll see some samples of that. Other Americans involved in refractor telescope making were these two engineers, Worcester Warner and Ambrose Swayze, who ran a machine shop making turret lathes in the late 19th century in Cleveland, Ohio. And they all went on to make the mountings for many of these big refractors. And another telescope maker, American telescope maker, who was prominent at this time was John Brashear. And he has made a number of large refractors as well. And we'll take a look at some of those. This is a 30-inch Brashear refractor that was built for the Allegheny Observatory in Pittsburgh. It's just outside of Pittsburgh, Pennsylvania. I was supposed to have gone with the ATS to see this telescope in 2001, but unfortunately it landed on the week that the 9/11 incident happened, and so the worldwide air transport system came to a halt, and we have never been able to get back to this observatory. However, the East Coast ATS members did go ahead and have their meeting, and those who could drive to the observatory went ahead and had a chance to look at this telescope, which is still there and it's being used as a public observatory. Another beloved Brashear refractor that we all know and love is the 20-inch at the Chabot Space and Science Center, and that was installed there in 1915. Actually, it's been moved around a fair amount, but it's in its current location, I think, as a result, as recently as I think about 2000 or thereabouts. Okay, well, the Clarks went on to build the world's biggest refractors, and this is our beloved 36-inch up at Lick Observatory, which everybody here probably has already been to see and to look through. And then they built the lens for the 40-inch at Yerkes Observatory, which you can see here. And let's see. And it was mounted by the Warner and Swayze company, who built the tube assembly and the mounting. Here's a little short video of the Yerkes refractor that John Briggs, with John Briggs hauling the thing around. All right, let's see. Well, let me see if I can. Oh, there we go. Then the biggest refractor ever made was the great Paris refractor, which is actually 49 inches in diameter. And it was so large, and it had a focal length that was so long. I think it was. Let me see if I can get the specs here. Yeah. So this thing had a lens made by Paul Gaultier in France that was 49 inches in diameter and a focal length of 187 feet. So it was clearly not a telescope that you could mount in a mobile kind of way. And they laid it out horizontally with the starlight being fed to it via a siderostat mirror. This thing was set up as part of the Universal Exposition in Paris of 1900. And although the builders of the telescope had hoped that astronomers would make use of this thing for research, it turned out that no professional astronomers found it to be useful for any kind of research that they would be interested in. And then they tried to turn it into a tourist attraction, but it didn't sell enough tickets to remain economically viable. So eventually, the telescope was taken down. The metal parts of it were scrapped, but the lens has been salvaged, and is in the possession of the Paris Observatory. It's not on display anywhere, unfortunately, and from what I have heard, it's almost impossible to get anybody to do a tour of the Paris Observatory. I think Ken Lum in our group was able to get a private tour of the old Paris Observatory, but that's about where it stands. This was the largest refractor ever built, but it's not operational any longer. And then this is the strangest telescope I've ever seen. This is a 27-inch refractor that was built by Karl Steinheil in Germany. It's in a public observatory outside of Berlin. And let me show you this video clip because it's really weird. It's known as the Himmels Kanone, or the celestial cannon, and you'll see why. Anyway, the telescope is designed to pivot around the base near the eyepiece so that the eyepiece wouldn't move around in a large arc. And members of the general public could come and look through the telescope by going on a catwalk down at the base of the telescope. But it really looks like an artillery piece. Then there are these big steel arms that hold counterweights. Anyway, the telescope was built it's called the Archenhold Observatory, and Archenhold was the person who arranged the finances for it, and it was built for the Industrial Exposition of Berlin in 1896. Fortunately, the telescope escaped the bombings of Second World War, although an adjacent building was destroyed by one of the bombs, but the telescope itself was not harmed. And so after World War II, the telescope was refurbished, and you can actually go to Berlin and look through this thing. It's still operational to this day. All right. Let me go. Okay, well, anyway, moving on to the 20th century, we see the switch to reflecting telescopes beginning in 1900, and mountings with very capable of very heavy loads were starting to be developed. Aluminum reflective coatings were developed in the 1930s by John Strong at Caltech. The Schmidt Camera was invented in 1930. Multispectral observing was enabled, which is to say that you can look at astronomical objects in many different wavelengths. Computer-controlled telescopes came into being in the latter part of the 20th century. Adaptive optics was invented, starting in the 1950s with Horace Babcock at Mount Wilson, and then Jerry Nelson at UC, and Roger Angel, University of Arizona, Robert Fugate from the Air Force, and Claire Max at UC Santa Cruz have had a hand in developing adaptive optics. Space-based telescopes are the thing now. CCD imaging was another new development of imaging that improved on the old film. And then nowadays we have consumer telescopes for amateurs. Okay, well, the switch to back to reflecting telescopes, as you can see from the refracting telescopes that you saw earlier, became very cumbersome and difficult to use. They couldn't be made in larger sizes. It was too difficult for them to be made in fast F ratios. And so some people began to take another look at reflecting telescopes, given that silver and glass mirrors were possible now. And the two people who did the most with this were Americans, George Ellery Hale and George Willis Richie. They met in 1891 in Chicago. George Hayo was born in Chicago, and he was born to a wealthy family. His father, William Hale, had made his money inventing and installing elevators on the new skyscrapers that were going up in Chicago in the aftermath of the great 1871 Chicago fire. And George Willis Richie came from Ohio, from a furniture making family, and he moved to Chicago to establish a business in furniture making, but got interested in astronomy further back as a young man when he was looking through the telescopes of the Cincinnati Observatory in Ohio. Anyway, Hayo grew up, actually, he lived for a while in this mansion on the south side of Chicago. This is actually the Hale, the mansion that William Hale built for himself and his family. It's the address of it was located in Don Osterbrock's book about Hale and Richie. It's at 4545 South Drexel Boulevard, if anybody's interested, near 46th Street. So I was able to locate the thing and take some pictures of it. It's now subdivided into a series of apartments, but it's still there. The backyard of this estate had a 12-inch Clark refractor, which the elder Hale had purchased and built for his son after he had come back from getting a bachelor's degree at MIT. And he set this up as the Kenwood Astronomical Laboratory. And it was here that he perfected his invention that he came up with while at MIT called the spectroheliograph. And he continued to do work financed by his father on solar physics, actually. Now, this work got the attention of William Harper, who was the president of the University of Chicago, and he invited Hale to join the faculty at the University of Chicago. And after that, he went on to found the Yerkes Observatory with the 40-inch refractor up at Williams Bay, Wisconsin. Let's see. But both Richie and Hale were not satisfied with big refractors, and they wanted to know if reflecting telescopes could be used to make even bigger telescopes, because they needed more light gathering capacity. And so in 1900, Richie built this 24-inch Newtonian reflector at Yerkes. And with this telescope, he was able to work out the engineering inventions that were necessary to turn reflectors into high precision instruments. And this this telescope still exists. It's in the possession of the Smithsonian, and it's on display in Washington, D.C. if you want to see it. But when Chabot Space and Science Center first opened, the first director, Michael Reynolds, borrowed this telescope and put it on display at the Chabot Space and Science Center. And so many of you may have seen this telescope when it was there. Okay, anyway, Hale and Richie subsequently needed a better site than Williams Bay, Wisconsin, and they moved to Mount Wilson Observatory, to Mount Wilson, to set up an observatory there. And all this work was financed by grants from the Carnegie Institution, who had set up a foundation to finance scientific research. And so Hale and his instrument maker, George Willis Richie, developed this observatory, building initially the Snow Horizontal Solar Telescope down at the lower portion of this picture. Then subsequently the 60-foot solar tower here, and then the 120-foot solar tower over here some years later. And then he subsequently installed the 60-inch reflector over here in the smaller dome. And then this was in 1908. And then in 1917, he subsequently installed the 100-inch reflector in the bigger dome up above. Okay. And here's yours truly looking at the moon of all things with the 60-inch. When Richie built the 60-inch, he started taking astrophotos with this thing and produced really sensational pictures for the time, which were the finest astronomical photographs of celestial objects ever taken. And so he had made great progress in astronomical imaging. This is M81, taken through the 60-inch. And here's the 100-inch today. Both the 60-inch and the 100-inch are operating today. It's under the auspices of the Mount Wilson Foundation, who have taken over operations of the observatory. And so you can book time on these telescopes to go down there and actually look through them. Get a group together and go down there and actually look through these telescopes. The 100-inch was not initially used as a visual instrument, but my understanding is it has been changed, so reconfigured, so that people can actually climb up on the thing and actually look through an eyepiece. Okay, now this is the mirror of the 100-inch as it was delivered with its and this is what it looks like with its reflective coating stripped off. When the mirror blank arrived, it was made by a glass making company called Saint Gobain's Glass Works outside of Paris, France, and it was all full of bubbles. You can see just a big sea of bubbles inside the glass disc. And when Hale and Richie looked at this, they thought that they really couldn't use this thing to make a mirror initially. And they took delivery of the thing in 1908 and just thought they couldn't use it. Evidently, what Saint Gobain did was they made the mirror in 3 pourings, because their ladle was only big enough to hold 1/3 of the glass necessary at a time. And so you can see there are 3 layers of glass here. And the first 2 layers generated enormous numbers of bubbles in the glass. However, Hale noted that the upper layer, the bubbles did not extend all the way up to the top surface of the glass. And so after several years in which they asked Saint Gobain's not to try and make another blank, and having failed, and then World War I closed in on them, and they couldn't make it do anything at all. They turned back to the first mirror and figured that they could grind a reflective surface into the top surface of the mirror and not hit any of the bubbles below, which Rishi was able to do actually. And ultimately he was able to make a really fine parabolic surface on this glass despite all these bubbles. Also, the engineers had done some calculations on the effect of the bubbles on the structure of the mirror and figured that the bubbles actually maybe strengthen the stiffness of the mirror, making it easier for the glass to hold a figure. It turns out that to my surprise, the Saint-Gobain glassworks is still around. And it's one of the oldest companies in existence. It was established by Jean-Baptiste Colbert, who was the finance minister to Louis XIV in the latter part of the 17th century. And this company has survived the French Revolution, the revolutions of 1848, the Franco-Prussian War, World War I, World War II, the Great Depression, etc. And it's still in business after almost 400 years. And so to my great surprise, when I was in Leipzig, Germany back in 2015, I saw one of their trucks across the street from a railroad station that I was about to take to go into downtown Leipzig. And so I shot this picture and then, wow, this company's been around for a while. So there we have it. Okay, now Mount Wilson, as most of you know, is one of the most productive observatories ever established. And these are just a few of its major discoveries. Hale discovered magnetic fields around sunspots in 1908. These were the first extraterrestrial magnetic fields ever discovered. White dwarfs were discovered by Walter Adams in 1915. The size of the Milky Way and the location of the solar system in the Milky Way was established by Harlow Shapley in 1918 using the 60-inch to map out the three-dimensional distribution of globular clusters around the Milky Way. And I put in Henrietta Leavitt's name here because the technique that he used to establish the distances to these globular clusters depended upon Leavitt's period luminosity relationships found with Cepheid variable stars. And so although Leavitt herself never went to Mount Wilson, her technique was crucial to the work of Shapley and later on of Hubble, who established that that galaxies are external to the Milky Way in establishing the distances to faraway objects. And then in 1929, Hubble and his assistant Humason established the existence of the expanding universe. Richie and Henri Kretian invented the Richie-Kretian telescope at Mount Wilson. And Walter Baade in the 1930s, who was a German migrant who took a fellowship at Mount Wilson and stayed through the Second World War, actually was interned on the mountaintop with the world's largest telescope, while all the cities around him were blacked out, being worried about attacks from the Imperial Japanese Navy. Anyway, he discovered distinct populations of stars in the Andromeda Galaxy and other galaxies subsequently. Okay, we also visited Hayo's retirement house, which is located just south of the Caltech campus. It's a national landmark nowadays, and it does actually hold a tower solar telescope, which Hale used for his amusement during his retirement. This is the library of the house, and it has many Egyptian motifs in it as part of its architecture because Hale was a solar astronomer, and his friend James Breasted was a Egyptologist back at the University of Chicago. So there are many Egyptian motifs having to do with the Egyptian sun god Ra distributed throughout the building. But this is the library, and this is where the initial discussions for the building of the 200-inch Palomar telescope started. This is a private residence, so you can't actually, as a member of the public, buy tickets and go in there for a tour. You have to make a long prior arrangement. But we were lucky with the ATS to be able to go through this house. Okay, anyway, Hale went on to start the ball rolling on building an even bigger telescope than the 100-inch at Mount Wilson, and that was the Palomar 200-inch. Hale died in 1938, unfortunately, and so he was not able to see the finish of this great telescope. And for most of my early life, this was the world's largest telescope at the time. And this telescope brought with it a large number of innovations that made big telescopes possible. One was the development of aluminized reflective coatings on mirrors in a vacuum chamber. As I mentioned, that was invented by John Strong at Caltech in 1936. The large weight of the telescope is supported on these oil pad pressure bearings on both the north and south side, and also on the declination axis, which support the 50 tons of telescope on thin oil bearings with almost no friction. They were originally going to use large ball bearings to support the telescope, but the engineers discovered that the weight of the telescope would deform the steel of the ball bearings and make the telescope unmovable. So they had to come up with another idea. And that idea came from a Westinghouse engineer by the name of Ryan Kroon, who came up with the idea of floating the telescope on thin pads of oil on the north and south side, and also through the declination axis. Let's see, moving on. They also made the disc of the mirror into a honeycomb shape to lighten the weight of the mirror. And here's yours truly looking up the Coude focus on the south end of the telescope mounting. I think the most interesting person associated with the Palomar project is Russell W. Porter. He was an architect and an artist who was born in Vermont in 1871. And he early in his life, he went on several polar exploration expedition, which was a big type of research that was being done at that time. A number of other people were doing it, like Robert Scott and Amundsen and was it Shackleton, for example, went down to Antarctica. So anyway, but after he retired from that, he settled back in Vermont, in Springfield, Vermont, and he started the amateur telescope making movement and set up the well-known Stellafane meeting in Vermont that still meets to this day annually which is an annual convention for amateur telescope makers. Anyway, Hale heard about him and decided to hire him on as on the staff of the Palomar project. And the big thing that he brought along with him was artistic skill. And he was able to do these spectacular cutaway drawings of the Palomar telescope and its components before they were built, kind of like a CAD/CAM drawing, although these were done on paper and pencil long before the existence of computer-aided design. And here's an example of one of his drawings of the main mirror of the 200-inch Palomar telescope, along with its retractable mirror shield and some of its support mechanisms. So there's a whole atlas of these drawings that you can purchase from Caltech, and I have a copy of it. But all the drawings are actually also on the internet. So if you Google Russell W. Porter drawings, you'll find essentially all of them And just admire what a fantastic work of art these drawings are. Okay, another big invention was the invention of the Schmidt camera. This was done by Bernhard Schmidt in 1930. Schmidt was born on an island called Nargen in 1879 off the coast of Estonia, and he ultimately ended up at the Hamburg Observatory, hired on as their instrument maker. As a child, he was playing with a pipe bomb, and one of them blew his right hand off, unfortunately. And so for the rest of his life, he didn't have the use of a right hand. But nonetheless, he became a superb craftsman of optics, and got himself a job at the Hamburg Observatory, where he continued to make excellent optics. But he was also innovative, and he went on to here's the dome of one of the domes at the Hamburg Observatory, which we visited in 2012. He went on to invent the Schmidt camera, which was a wide field camera of a very short f ratio, which provided perfect star images across the entire field, something that most reflectors couldn't do. At Hamburg, in Bergedorf, the Hamburg Observatory, there is a one-room museum devoted to Schmidt, and here it is. And this is the world's first Schmidt camera, built by Herr Schmidt himself in 1930. And it was this demonstration model that showed the world that the Schmidt cameras could be made to produce wide field pictures of the sky that had perfect star images across the entire field. However, when he invented this thing, he only revealed the how to make the corrector plate of this telescope to only two people. One was his boss, Richard Schor, who was the director of the Hamburg Observatory, and to Walter Baade, who was a young colleague of his at Hamburg. And Baade subsequently took the secret of the Schmidt camera with him to America, and showed American telescope makers how to make one. And so that ultimately led to the production, to the construction of Schmidt cameras at Palomar to supplement the work of the 200-inch. And there were two Schmidt cameras built at Palomar during its construction. One was an 18-inch, a smaller 18-inch telescope, 18 inches in diameter for the corrector plate. The main mirror is bigger, and then there's this 48-inch, which is down there, now known as the Ocean Schmidt, and after its benefactor. The corrector plate for the Ocean Schmidt is 48 inches in diameter, and the main mirror is 72 inches in diameter. And this was used in the 1950s to do the National Geographic Sky Survey, Palomar Sky Survey, which has become really famous. That survey has been done twice. One was a version done in the 1950s, and then in the 1970s, they did a second survey with improved photographic plates. And so this telescope is now still operational, although the plate holder in the middle of the tube assembly is now substituted with CCD image detectors now. Oh, here's Edwin Hubble posing with the real 48-inch Schmidt. The largest Schmidt camera in the world was built by the East Germans, actually. And this was a Schmidt camera that was built out in the Teutoburg forest in East Germany. It's slightly larger than the Palomar Schmidt, and I think it has a 78-inch mirror and a 52-inch corrector plate. And here we had a chance to take a look at one of the corrector plates for this telescope. and that's our host in Hamburg, Gudrun Schmidt, who was touring the facility with us. So the observatory, I think, is called the Karl Schwarzschild Observatory. So if you have a chance to go there, that it's just a great place to take a look around. Okay, well, after the Palomar telescope was built, astronomers, of course, still wanted bigger telescopes, but the old technology of big heavy mirrors and gigantic mountings was not practical, could not scale up past the 5 meter at Palomar. So this person at UC, Jerry Nelson, came up with the idea of making lightweight mirrors out of segments, and the result of his effort resulted in the what's that? The dual 10 meter telescope on Mauna Kea. Gosh, I'm having a senior moment on this, and anybody can remind me. But anyway, he figured that he could get the lightweight mirrors to act together by controlling them with actuators mounted in the framework behind the mirror, and so he was successful in doing that, and we have continued to work with that technology, most recently with the James Webb telescope. And then another telescope innovator, Roger Angel, at the University of Arizona, developed a spin casting oven, which is located under some football stands at the University of Arizona, which can take molten glass and spin it around to, as it annealed and hardened, to auto-generate a concave surface on the glass disc. And since these were that was the Keck Observatory at Hawaii. I'm sorry, I was forgetting the name of that. But anyway, using these spin cast ovens, he's able to generate these 8 meter discs, thin discs, that can be used to make really big telescopes. And among them are telescopes that are using these kinds of mirrors is the very large telescope down in Chile, which the European Space Agency has set up, and so forth. These mirrors are very thin, and so they're actually flexible, and they can flex under their own weight. And so by putting computer-controlled actuators under the mirror, you can impose a kind of adaptive optics to this kind of telescope to compensate for the degradation of seeing by the Earth's atmosphere. Okay, now we have space telescopes, which everybody knows about the Hubble Space Telescope. And now that's been up there for 32 years now, no less. One would wonder whether to consider it to be an antique telescope. And there is an interesting artifact associated with this. You may remember that the mirror for this telescope was misshapen, overcorrected by the company that made it, the Perkin-Elmer company. And so NASA flew that mirror up with the telescope, and 3 years later, the NASA had to fly another space shuttle mission up to this telescope to add some corrective mirror called the COSTAR instrument to correct the spherical aberration that resulted from it. But there was a backup mirror that was made. The notion of a space telescope was developed by this astronomer, Lyman Spitzer, who was at Princeton, and he came up with the notion as early as 1946, actually. But there was a backup mirror for the Hubble Space Telescope, which you see here. This mirror was made by Eastman Kodak, and it has never been flown, but it turns out that this mirror is perfectly figured, and unfortunately, NASA made the mistake of flying the imperfect mirror into the sky, whereas the perfectly figured mirror by Eastman Kodak sits on the ground, now on display at the National Air and Space Museum. So anyway, finally, we have brought all these technologies together in the most recent big telescope that is up there, which is the James Webb Telescope. And when I made this slide back in 2021, there was a question mark as to whether or not it would fly in 2021. And it did not, but it finally flew last Christmas Day, actually. And we have discovered that the thing actually works, which is amazing. So I'm looking forward to some spectacular photographs coming down from that, and great research coming down from that telescope. So anyway, to bring things to an end, full circle, I wanted to bring us back to the original 1608 patent for the telescope by Hans Lippershey, and just to remind us how much progress we have made given 400 years of invention and innovation. Okay, that's the end. Thank you.
Well, hey, fantastic. Wonderful. Thank you.
Okay, let's see. How do I get out of this?
Um,
Or you'll take me out of
course.
screen share.
Stop participant sharing. Hey,
Here we go.
there
Okay,
we
good.
are.
All right.
And Linda, you're on mute. But thank you very much. That was a wonderful tour of history and of the world. And we're glad to take any questions any of our attendees might have. You can type them into the chat, or you can click the button to raise your hand, or you can just unmute yourself and speak up if you like that as well.
Let me see if I can find the chat.
Oh, well, when they type into the chat, I'll read them aloud. So
okay.
No worries.
I can see the chat now. Okay.
And Linda's come unmuted. Did you want to say a word, Linda?
Oh, I just wanted to thank you, Ken, for the incredible amount of information you gave us tonight. And I'm so glad it's recorded so that we can see it again. Yeah, I did have a question. I need to go back and see where my notes are for the question. Oh, we're Henrietta Leavitt and the women at the Harvard, what did they call the Harvard Observatory? What kind of telescopes was being used when the very, very first little glass images were made for the women to look at to determine the composition of the stars and apply the "Oh, be a fine girl, kiss me" classification to them years ago. What was the original telescope that was being used, and then what were the ladies using? What was being used for the slides that the women used that were later at a larger size?
Well, the women got the photographic plates that were taken mostly by the men who operated the telescopes, and
right. But there was one.
The telescopes that were used on the Harvard campus at the time were mostly actually small photographic lenses. They were called Cook portrait lenses, and they were sort of derived. Their design was derived from designs by Josef Fraunhofer and any number of other telescope makers who came up with the specifications that they found that actually worked. One has to remember, back in the early 19th century, there was no mathematical way to calculate ideal lens set specifications. A lot of the work was just done by trial and error. And if they, by chance, came up with a lens specification that worked for one example, then they would record what those surface radii were, and then try to scale it up either to a larger size or scale it down to a smaller size, in the hopes that the lens would work as well as the original prototype. And it was not until Ernst Abbe came along and developed a mathematical theory of ray tracing that engineers could actually calculate the performance of a lens before they ever actually started grinding glass. So it was a difficult art to learn at that time, because it was not much science. It was all art. But the telescopes that the ladies you worked with, they didn't actually use the telescopes themselves, but they got the photographic plates of the spectra from those telescopes, and then worked with them there in the observatory building. They also got plates from South Africa, from the Harvard station down in South Africa as well, and they worked with that. In particular, what was most useful initially for Henrietta Leva, she got the photographs, actually not so much spectra, but photographs of the large and small Magellanic Clouds, and it was the photographs of those two objects that allowed her to establish the period luminosity relationship for Cepheid variables in those galaxies. I'm not sure that Henrietta Leva ever went to South Africa herself. I think she was. I think photographic plates were brought to her, and she worked with them in Massachusetts. But I'll have to look. I have to look that up. I don't know that for sure.
I had asked you before we began if you had any familiarity with Midwestern observatories. I myself am from Iowa, and when you mentioned the story of the stolen mirrors
lens, yeah,
the lens that ended up in Cincinnati. I think I recall hearing that story when I visited there a number of years ago. And
yeah, that
where
was
did
very,
you?
very interesting. There are two observatories. There's two astronomical establishments in Cincinnati. There's a Cincinnati Observatory, which has a Mertzen-Mahler 11-inch and a 16-inch refractor on its grounds, and that's a public observatory that was set up in 1843. Separate from that, apparently, is the Cincinnati Astronomical Society, which is an amateur organ, and they have a dark sky site somewhere out there. I'm not exactly sure, but that's where their 8-inch refractor is located, and that was the one from which the lens was stolen, and then they purchased the Huggins Clark lens to replace that, and then got the 1880 lens back after the thief was discovered some 18 years later.
I wonder why. And then so did they ended up keeping the stolen one as well?
Yeah, they kept. They got the lens originally belonged to them, and so they got the item back, fortunately in good shape. Which lens they are using on the 8-inch refractor tube assembly in the present time, I'm not sure. I've never been there actually, so I've never met any of the people. Although the ATS did visit the Cincinnati Observatory, the city observatory from 1843, I did not go on that trip. I didn't fully realize the historic import of the Cincinnati Observatory at the time.
I recall when I visited.
It is the oldest observatory in the U.S.
Yes, they're very proud of that. It is an important note. And they had a I don't know the proper name for it, but a ball clock where they would they would drop the ball at noon to tell everybody in sight that this is the hour of noon.
Right. That's called a time ball. Yes. That custom started at the Royal Greenwich Observatory when the RGO became the place where all the sea captains set their chronometers, their navigation chronometers, before going on their voyages. And what they did was they dropped the ball at precisely 1 o'clock in the afternoon each day. And so they decided to, for whatever reasons, I don't recall exactly, but they always dropped the ball at 1 p.m. rather than at noon. It's my understanding.
I don't know why the British do it at 1 instead of noon. But yeah, I like the American way of 12 o'clock noon.
Yeah, it's really at noon.
In the Cincinnati Observatory, they had their most important clock down in the basement in a very climate controlled room. And then they had they have a series of mirrors that so that you can view the exact time from upstairs in the observatory just by looking into this window piece that would kind of like a periscope down the basement clock.
Sure, that makes sense, because if you bury the clock underneath, it'll be at a more constant temperature. That makes sense. Yeah. But I don't know if they actually use that do they do that? You may have more familiarity with it.
They maintain it for the public tours, but it's mainly for the historical aspect now.
Right. Although it was useful in the 19th century, I suppose. Although I'm not sure how much you really need to know your longitude on Lake Erie. And you're not really near the Atlantic Ocean, and nobody there can see it. But anyway, it is still useful because observatories everywhere provided the time standard for every time zone up until recently. And so I know we have a transit instrument at Chabot Space and Science Center that's on display there that was once used for establishing time readings. And also Lick Observatory had transit instruments for establishing local time, and that information was delivered by telegraph to mostly people who ran the train system, for example, and whoever else needed to know time more precisely. Of course, now since the 1950s, we've had atomic clocks, and we have electronic transmission of information, and so those kinds of things are just museum pieces now. But it's kind of fun to see how people had to keep track of time in the old days.
Yes. Well, I'm not seeing any questions pop up in the chat, so
okay. Well, anyway,
I think we might end this one, huh?
Okay.
But thank you very much. I really enjoyed this continuation of the first part of this lecture, which we did in the spring, and so it was good to round it back out and complete the history. Thank you.
Okay.
I just also wanted to make a comment that anyone is interested considering to volunteer for the position of program chair, speaker chair, please contact President at SFAA, go to the website, and I have a tremendous amount of information to give to whomever might choose to be the person to do this task, which is a delight, but it also needs focus and information and persistence and flexibility and those kinds of things. I will be delighted to share the information I have gleaned over the years with anyone who chooses to do this delightful job.
And Prasad writes into the chat, thanks very much for this wonderful history of the telescopes.
Yes.
Thank you, Prasad, for attending. Thanks, everyone, for attending.
Thank you, Ken.
Okay. Thank you. That was great. It was a lot of fun to share this information. Oh, by the way, I wanted to mention that, as I said, the ATS is not currently having any tours on its schedule, although in 2020 they had attempted to set up a tour of Florence and Rome. So they would be a great opportunity to go take a vacation in Italy. But I don't know when they're going to open that up as yet, and I'm not sure if they're still going to go to Italy under the circumstances.
Oh, if people are interested in finding out more about the Antique Telescope Society, is there a place you recommend online?
Yeah, they do have a website. You can find it just by Googling Antique Telescope Society. They also
Okay.
have a group on groups.io, which is labeled under ATS. Let me see if I'm getting any recent messages from them. But anyway, but you can go on groups.io and find their discussion group there as well. So they have those two ways of communicating at this time. And if you're really into the esoterics of old telescopes, yeah,
I might be.
and
I might be.
that gets to be pretty strange sometimes. It's almost like a friend of mine who has now passed, but he used to be a member of an outfit called the German Stamp Society, and although it's interesting information, it really gets weird. But it can be quite entertainment, quite entertaining to see. But it's a great story of how innovation can produce a tremendous instrument, a tremendous technology that can reveal things to us in ways that can't be found any other way. I mean, without the telescope, think about it. Without the telescope, we would know nothing about what's up there. Absolutely nothing. We'd not know about spiral galaxies. We would not know what the planets look like. We would maybe still be stuck wondering what the surface of the moon was like. Talk about be our nearest neighborhood. It probably is the most perception changing technology ever developed. It just showed humans how big the universe really is and what's all in it. And so it's really a mind-changing, mind-blowing type of technology, without which we'd still be stuck in the who knows what.
Yes.
I also want to thank you, Ken, for making sure that the SFAA lectures get on Bay Astro, where they get published every Monday.
Right.
And we get
Right.
to be a part of and get to see all of the various wonderful talks that are presented in the Bay Area every Monday at Bay Astro. And thank you for all these years sending the information to Bay Astro from SFAA.
Okay, you're very welcome. Thank you.